algebra students. All right, today we're going to look at multiple graph transformations. And to start with, let's look at this first example. It says g of x is the absolute value of x minus 5 plus 2. There's a couple things happening here in terms of graph transformation. And let's review graph transformation real quick. Here's a list of all the translations and reflections and stretching and stuff like that that happens when you're transforming a graph. So let's say we have a graph f of x. What happens if we add something to it? Well, it's going to move the graph up. It's going to translate it up. If we subtract a value, it's going to translate down. It's like changing the y value, right? F of x is a y value. If we add something to the y, all the y values, the graph's going to move up. If we subtract, it's going to move down. A little more strange and involves function notation is if you were to substitute x minus some value c or x plus some value c into the function, what happens? Well, maybe counterintuitively, the minus means that the graph's going to move to the right by an amount c. If it's adding, it's going to move to the left. If there's a minus sign outside the function, that's going to reflect the graph about the x-axis. And if the minus sign is inside the function, it's going to reflect about the y-axis. Then you can multiply the function by a value, and that's going to vertically stretch it or squish it. And then if you multiply by all the x's in the function, you multiply all the x's by a constant, you'll horizontally stretch the graph. All right. Let's go back to our example here and think about what's going on here. A lot of times you could just look at these and see what's going on. This plus 2, that's adding to the whole function. So we assume this is up 2. And this minus 5 is inside a function like absolute value. This is moving the graph to the right by 5. The basic function you can see here is what? If you remove the minus 5 and the plus 2, you would have something like absolute value of x, right? And so we all know what the absolute value of x looks like. It's sort of this V-shaped graph. And that's the shape that's moving right by 5 and up by 2. You can kind of illustrate what's going on by, well, if I took 2 and added it to both sides of this expression that I just showed here, you can kind of see how the f of x plus 2 matches what we had over on the other page I just showed, where it was f of x plus c, and that meant we were moving up. So we're moving up by 2. And to illustrate the moving right, if we said, well, what's f of x minus 5? So wherever there's an x, we put x minus 5. Whoop, I want an equal sign in there, sorry. Plus 2. And you can see that by doing that, we now have the full function g of x. You don't need to know all this function notation stuff at the moment. Just if you can recognize what the pieces are for a multiple transformation, that's good enough. I should mention that if there's a lot of things going on at once, sometimes the order in which you do the transformations is important. With 2 translations, it doesn't matter. If you were to move the graph of the absolute value of x to the right 5 and then up, you'd get the same graph as if you moved up first and then moved it to the right. Okay, well, let's graph this thing. Let's make a little room here. our basic graph looks like this. Some important values are 1 and 1. We have a point 1 and 1 on the graph. The origin is on there, and the point -1, 1 is on there. And those are good points to use to find the new location. So let's just say we're going to move right 5 and then up 2. So the origin would move right 5, 1, 2, 3, 4, 5. Did I go to 5? 1, 2, 3, 4, 5. Yep. There it is. And then this point at -1, 1, if we move that over by 5, 1, 2, 3, 4, 5 to there. And then this point, the 1, 1 point over 5, 1, 2, 3, 4, 5. That's at 6 on the x-axis. I should label that, I guess. This is 4. We can see that that's moved us to the right by 5 units. And now we have to move up. So we're going to take those 3 points that we just moved and move them up 2. So this point goes up 1 and 2 to here. The point that was originally at the origin and moved to 5, 0, that goes up 2, 1, 2 to there. And then this one goes up 2. So I'm trying to get to there. It's a little messy, sorry. And then I can graph it through those points like that. So what did we do? We moved to the right. I'll label this by 5. And then we moved up by 2. So this is g of x right here. And I should probably label some things on my axes. So I label it 1. Here's 2. This is 3. This is our y-axis here. I think I've got values on for all the points that I've got. Maybe I could bring some construction lines down to show where these points are. And maybe this V part there. There we go. Now we know where everything is, and we can see what happened. All right. Next, let's do something more complicated. Let's do something more complicated. All right, here it is. Now there's actually 3 things going on. And the basic function is a square root. You remember what the square, like a y equals the square root of x, that looks like this, with a point at 1, 1. That's a good point to remember. And the origin. Okay, so that's what this would look like without the +2 and the -3 and this minus sign out here. But what are those features doing? Well, it's kind of like before. The thing inside the function, which is the square root, is making it move left or right. And because it's a plus, it moves to the left. So this is left 2. The -3 on the outside is down 3. And then a negative outside the function means it's reflecting about the x-axis. Reflect about x-axis. All right. This one, we really need to be careful about the order that we do this. Otherwise, it won't come out right. And I should have tested some points in the previous example, but I didn't do it. I'll do it with this one. Let's go to the next page where I want to talk about the order that you do this in. So here's the order. You're supposed to do horizontal translation, then stretching, then reflection, and then the vertical translation last. And so I've just kind of made up this mnemonic kind of thing. It's at HSRV, so I'm trying to remember HSRV. I thought, okay, heroic soccer, real victory, right? For all you soccer fans out there. So heroic soccer, real victory will give you the order in which you should do the transformations. Okay, let's go back. So, heroic soccer, real victory. We're going to do horizontal translation first. So that means we go left. So here's our graph. We're going to take our basic graph, and I'm going to just dash it to start with. Okay, so there's the 2 points. We really know where they're at. 1, 1. And we're going to go left 2, right? Horizontal translation first. Those are those 2 places. So now the graph's going like that. So I moved left 2. Stretching, there's no stretching, so we don't have to worry about that. But reflection about the x-axis. So this is where it flips over the x-axis. This point that's on the axis is going to stay right where it is, and this point is going to reflect down to this point. And so it's going to go like that now. Then we're going to go down 3 from there. Yikes, okay, I don't have a lot of room here. Okay, 1, 2, 3, just enough room. Okay, so that's going to go down to here. And this point out here, way on the left, that's going to go down 1, 2, 3 over to here. And now we're supposedly on the graph. So I'm going to draw it in with, whoops, I want to come down a little bit more than that. Okay, there we go. Let me erase that kind of bad line I just drew. All right. So where are we at? Let's mark everything. So this is -1, -2, -3, -4. This point right here is -1. This is -2. There's our origin. This is the y-axis. This is the x-axis. And now let's test our graph. Remember, we had g of x equals -x plus 2 minus 3. That should be absolute value there. All right. So at x equal -2, so g of -2, we're hoping to get -3. Let's see if that happens. So we have negative absolute value of -2 plus 2. Ooh, it's looking good, right? That's -2 plus 2 is 0. Negative of 0 is 0 still. We get -3. It worked. Okay, let's go to -1 and see what happens. G at -1. We're hoping we get -4. Let's see if that happens. So we have, whoops, negative absolute value of -1 plus 2 minus 3. Well, the absolute value of -1 plus 2, that's the absolute value of 1, which is 1. And the negative makes it -1. So this is -1 minus 3, and that's -4. And that worked. So I think we're pretty sure that this graph right here is g of x. All right, folks, I know it was sort of a long video, but I hope that was useful. We'll see you later.